In this lab, we will apply the concepts we know of ASTM and lineal intercept methods to compute grain sizes. We showed these concepts macroscopically on a turbine blade and microscopically on a photomicrograph of a piece of cartridge brass. For both of our samples, we will use statistical methods to create a 95% confidence interval of the ASTM and lineal intercept grain size.
To use the ASTM method on a curved object like a turbine blade, first acquire a piece of clear shipping tape. Using a permanent marker, draw a 1 inch by 1 inch square on a flat surface and let the tape dry. Place this piece of tape on a curved section of the turbine blade. Count the number of grains contained within this 1 inch square, counting grains that are not fully in the square as 1/2. The equation to determine the ASTM grain size is N100 is equal to 2 to the power small n minus 1. N100 corresponds to the number of grains in a 1 inch square in a 100 times magnified micrograph. Small n is the ASTM grain size number. As mentioned earlier, whole grains in the 1 inch square count as 1, and partial grains count as 1/2. For magnifications other than 100 times, use the equation N100 is equal to N sub m times m over 100 squared. N sub m is the number of grains at magnification m. For the lineal intercept method on the turbine blade, first mark a known distance on a small piece of paper with a pen. In our example, the distance we marked was 1 inch. Place the paper over the curved section of the turbine blade and count the number of grains that the paper passes through in the known distance. If the paper starts or ends inside a grain, count that as 1/2. To get better results, repeat the procedure multiple times, holding the paper in different directions each time. The equation for the lineal intercept method is lowercase l is equal to big L over n sub l times m. Lowercase l is the lineal intercept, big L is the length of the line that was drawn, m is the magnification, and n sub l is the number of grain boundary intercepts. As mentioned earlier, better results are achieved by taking multiple measurements of the lineal intercept in different directions. Taking an average of these values will give you a more accurate experimental result. Lowercase l in brackets corresponds to the mean lineal intercept. In order to get the caliper diameter, simply multiply the mean lineal intercept by 1.5.
To take a photomicrograph, follow these easy steps. The first step is to find an image using live preview and capture the image. Make sure to save the image somewhere easily accessible. We would recommend on the desktop. Now go to Image J and open up a scale bar with the scale corresponding to the magnification on the microscope. In our case, 100 times. With the scale bar open, select the line tool and draw a line a known distance. In the video, you're seeing a line being drawn 0.1 millimeters. Now with the line drawn, go to Analyze and go to Set Scale. Now in known distance, type in however far you drew the line to be. For us, 0.1, so that's what we type in. And make sure units are correct as millimeters and that global is checked. Now press OK and go back to Image J and open the image that you captured previously. Make sure that global calibration is enabled. And with your image open, go back to Image J, hit Analyze, Tools, and open Scale Bar. With this menu, you're able to change the settings and location of the scale bar to how you want it to look. And once it's the way you want it, press OK and your scale bar will be on your image. Pause now for a quick overview of everything that was just said. Also, if you do not change the magnification on the microscope, you can use the same scale bar for multiple images. If the magnification on the microscope is changed, you will have to go through steps 1 through 9 again to create a new scale bar.
Now that you've obtained the photomicrograph, use the lineal intercept method by drawing constant length lines on the printed out picture. Count how many grains are passed through along the line. If you start or end in the center of a grain, count it as 1/2. Do this multiple times in order to take an average. To get the caliper diameter, multiply the mean lineal intercept by 1.5. To use the ASTM method on your photomicrograph, draw a 1 inch by 1 inch square on a printout. Count the amount of grains within this square. Any grain that intercepts one of the lines will be counted as 1/2 of a grain.
For the statistical analysis section of this lab, it is convenient to know a few terms. Mu is the population mean. Lowercase x is the sample mean. Lowercase s is the sample standard deviation. Sigma is the population standard deviation. The standard error of the mean is sigma divided by the square root of n, where n is the number of trials. To find a confidence interval at 95%, use the equation mu plus or minus 2 times the standard error of the mean. When the population and standard deviation are unknown, a t-table is needed to determine the 95% confidence interval. This confidence interval is simply x plus or minus the t-value obtained from the table times s over the square root of n. With 10 trials in our calculations, the t-value we use to create the 95% confidence interval is shown boxed in red. Degrees of freedom corresponds to the number of trials n minus 1.
Thanks for watching. Hope you learned a lot and can now repeat this lab for yourself.